Welcome back, folks. Thank you very much for joining us. We hope everyone enjoyed your meal break and got rejuvenated and refreshed and ready to go on with 3 or 4 more modules regarding querying SQL Server 2012. I'm still in the studio with Tobias. He didn't bail on me over our meal break, so welcome back, sir. Thank you very much for staying with us today.
Thank you, and especially thanks to everyone who's, where there is 2 a.m. right now.
Yeah, exactly. We have it easy where we are. So let's just review what we've gone through so far. We went through, kind of just introduced just some of the basic statements and elements that are involved with SQL Server. Spent a little bit of time on that and talked a little bit about the basic select statement. We went into the module 2 and looked at advanced select statements. Really just introduced some clauses in there like distinct and some scalar function, case, the join, merge. Showed you how to filter and sort data. Then we moved into data types, talked about the different types of data types, the time and date data types, the character data types, and some of the functions associated with those data types that allow us to get creative with how those are displayed and what we can do with them data types. We then talked about grouping and aggregating data, not to be confused with aggravating. And we talked about some of the aggregate functions like the group by and the having, some of the subqueries available to us. And we had a couple really neat demos from Tobias on the views and the different tables, the derived tables, and the different ways we can work with that content. Then we took a 60-minute meal break, which was really nice. But now we're going to move back into some content. And we're going to move into Module 5, where we're going to discuss set operators. And we're going to talk about some additional Windows functions and some additional grouping options. Ways for us to, again, summarize some data. So we're going to talk about set operators, Windows functions, grouping sets, using things like pivots and cubes and roll-ups. So that's what we're going to dig into in this section here. So we've got some cool stuff left for us to be discussing. So let's open up this section with set operators. It's an interaction between sets. It's the results of 2 input queries that can be either combined, operated against, or even compared. Both of them have to have the compatible columns, same number of columns. You can't use the order by clause within there when you're looking at these input queries. Nulls are considered equal when you're comparing sets. And some of these set operations include unions and intersect and except and apply. The union operator, didn't we talk a little bit about this, Tobias, earlier?
I do believe we did.
I do believe we did. So there's nothing new here. We had a great demo from Tobias on this. It's how we can merge content from 2 different tables and put that into a single result set. So we will we're just going to go by this one because you've already seen a cool demo on that. In fact, Tobias used the union all statement. He showed you the difference between union and union all. So here's some sample statement on how you would perform that in the event that you were not able to follow that or had stepped away to the restroom. And now we're going to introduce a new one called the intersect operator. This returns only distinct rows that appear in both result sets. What does that mean to me, Tobias?
Well, it just means if you have, a list of, for example, employees and a list of customers by name, you may want to see, well, who of these people are both customers and employees?
Okay.
As an example. So then you would use intersect. So it gives you the intersection between the sets.
All right, beautiful. So that's really good to be able to take that content from 2 different tables and be able to bring it back into a single result set. The except operator returns only distinct rows that appear in the left set. Remember, if you talk left, we're talking about the first part of a query, but not in the right set. Does that make sense?
Yeah, so it's kind of, if you take the former example, right, show me all customers that are not also employees.
Not also employees. Okay, yeah. So there's a little bit different spin on it, but we're using the same tables, we're using the same, possibly the same columns, and we're accessing the same data, but it's a different result set that we want to work with. We then introduced the apply operator, which is an operator used in the from clause and can be either cross apply or outer apply. Your outer apply applies to the right table expression for each row in the left table, and the outer apply also adds rows for those with null in columns for a right table. Is there an example when we would want to use an apply operator when we're talking about the tables between the employee and the customer? Or do we have an example? I've got one here that's kind of listing that we can select the column list from the left table and give it an alias name. Then we can do a cross or outer apply. And then we use one of those derived table expressions that we had talked about earlier, or inline expression.
I can go ahead and show a simple demo.
Okay.
So in this case, let's just say what I want to show is all customers and the 5 last orders for each customer, right? And you can do this in many different ways, but one is using apply. So let's just say we're selecting from sales.customer as an example, and we're grabbing customer ID and account number. Right, now I want to go ahead and grab the orders. If I just do a join, there's no way for me to say, just give me the 5 latest orders. No way is a strong statement.
Right,
Since you can go ahead, you can use the row number operator or function to use to basically accomplish similar thing. But let's just say I want to do the apply. I want to use apply in this case. So now I can just say apply and give me the 5 top orders, sales order header here. And the thing with apply is it's executed now once for each row in the outer set, right? So now once for each customer that applies to whatever where clause we have. So let's say we have a where territory ID is equal to 3 as an example. So here I now say, okay, grab all orders where the customer ID is the customer I'm on.
Okay.
And now I can also say here order by, and I can use order by in this derived table just because I'm using the top operator. So order by, order date, descending, so I get the 5 last orders. And let me just grab what I need. Let's say I want order date and just order ID. And I'll call this set O. So now I can just say, okay, give me this from customer and these columns from order. And the difference between cross apply and outer apply is roughly the same as between inner join and outer join, meaning cross apply, I will only get customers that now have at least one order. Right. So where the inner query returns at least one row, and outer apply will give me even if they don't have any orders. I'll go with that. And there we go. So all of these first ones apparently don't have any orders. And as we scroll down, we start finding a couple of them with orders. And as you can see here, I'm getting 4 rows back for this same customer because that customer apparently happened to have 5 orders. So we're showing up to the 5 latest orders for that customer.
Gotcha. Good. Awesome. So this is another way for us to slice and dice our content and come in with just the customizing that result set. That's what this has been all about pretty much is what we've got all this data out there. I mean, there's just be so many ways for me that I want to be able to slice and produce a result set that's going to give me exactly what I need to generate the information and supply the information to management regarding what's going on with a particular employee or a customer or a salesperson. So all sorts of ways to slice and dice the content to be able to get to that data and create a result set that's going to meet the needs that you have. So let's move into our next section, which is Windows functions. We have some Windows functions. We briefly introduced a couple already. Tobias did a great demo on one earlier on. And within here, we're going to look at SQL windowing, which extends the T-SQL's set-based approach. We've been talking about set operators. They allow you to specify an order as part of a calculation. They allow partitioning and framing of rows to support certain functions. And they can simplify queries by running totals or moving averages or maybe even gaps in data. We're trying to find when there was a lull in a sales environment or something. So the idea of partitioning windows or partitioning limits a set to rows with the same values in what's called a partitioning column. We use the partition by statement in the over clause. And without a partition by clause defined, the over creates what's called a single partition of all these rows. So as you can see here, we have a select customer ID, order date, and total due. We're going to get an aggregate function of sum, the total due, create us a total due for that particular customer. Then we have the over partition by the customer ID. That's what we're going to create this content on as total due by customer. And we're going to grab this information from sales.sales order header. So you'll see that customer ID 1100, order date August 1st, 2007. I was trying to read it the other way. Has a total due of 3756, but the total due by the customer is 9115. Now, if you look at, there's 3 rows here for customer ID 1100. If you look at total due is 3756, then 2587, then 2770. If you add that up, you're going to see that those 3 values will come pretty close to that 9115 dot 1341 if you want to get down to the nano pennies or whatever that might be on the right side of that decimal point. And notice we have the order date where we are just displaying the year. We aren't displaying the actual the time associated with that. So this is an example of where we can retrieve information about a particular customer on different orders, what the due date, or what the amount was due for each order, and oh, by the way, what's the customer owe me as a total for that order. So we had for that particular customer, not specific to that order, but for the different orders that they've submitted to us. This would be a cool way for us to find out if anyone's kind of got this outstanding or ginormous amount of money that's due to us. We can actually sort this and set this up so we can see who owes us the most money, so we know who to send our accounts receivable people afterwards. How do we use this? We created a Windows function. It's applied to a window or set of rows. As we saw, it can include aggregate, it can include ranking, distribution, even offset function that we introduced earlier on. These are similar to grouped aggregate functions such as your sum, your min, your max. They're applied to windows defined by the over clause, the OVER, that's uppercase, so we can recognize that as a clause that we can use when we're working with Windows functions. And they support partitioning, ordering, and framing of content in the Windows world. Now, the ranking functions that are available to us, we have rank, dense rank, row number, and end title. The rank returns the rank of each row, and it may include ties and it may include gaps. The dense rank returns the rank of each row, but this also may include ties, but it will not include gaps if there's any gaps in the content. The row number returns a unique sequential row number within that partition based on where it is in that current order. And the end tile, distributes the rows in an ordered partition, and this returns the number of the group to which that row belongs to, so I can kind of figure out how they're categorized and where these rows belong to. The Windows offset function, I believe we looked at this earlier, but this actually looks at the lag where it returns an expression from a previous row, and it's defined in the offset from the current row. The lead, again, returns an expression from the later row instead of a previous row. First value, last value, pretty self-explanatory, returns the first value in the current Windows frame or returns the last value in this current Windows frame.
So let me go ahead and demo this a little bit, because like I mentioned earlier, this is one of these things where you need to get into a Zen place and then you'll basically be happy. It's one of these super useful functions.
So after this demo, I'm going to be happy for life. I'll be in Zen. I'll be there forever.
I'm not sure about forever.
Not forever, okay. At least for the rest of this module.
And you still use Fahrenheit, so I'm not so sure about this whole
Okay.
thing. Okay, let's go ahead and have a look. So I've just created a table I call transactions, because a banking kind of transactions makes a fairly useful example. So in this table, and I just stole some columns from the customers or from the sales order header and sales order detail tables and pretended transactions. Mm-hmm. So I apparently have account number, account ID, transaction date, and how much money they use in this transaction. So let's just start by looking at one account number. So where account ID equals this one. And let's say what I now want to calculate, which is a very common thing, and it was very problematic before SQL Server 2012, especially with regards to performance, is, okay, I have all of these transactions, but what is the current balance of the account? Right? Per a given row. So let's say we have this query now, and I can start by just using this aggregate. It's a sum I want, right? Sum over amount. And we know that we can't just do this because we need to group by, but I want to show the details. I want to show, okay, at this particular moment in time, this transaction happened, and the balance after the transaction is the following.
Okay.
So we'll start by just doing over partition by account ID as current balance, or let's just call it final balance. So what this will give me is the sum across the whole account, right? So now you can say, okay, the balance of this account is apparently 422,000, whatever pirate currency we're using here.
Okay.
And then what I can do now is, okay, that's fine, that's the end balance, right? If I tell the server instead to say over per account, because I want this per account, I will just do this so it makes it a bit easier to read. I want to say, give me the balance up until the current transaction. And what that means is I need an order in here, right?
Right.
Order doesn't matter when you group, logically, but it does matter when you want to do a cumulative thing. So here I'll say, well, order this by, not order date, transaction date. And since transaction date isn't unique, for me to be sure that this makes sense, I'll include transaction ID in there. And then I'll also use the same order by in the query. So I'll do this so that we are sure that we get the results in the same order. And it's important to note that if you put an order by clause here, you may get the result in this order, but that's just by accident.
Okay.
So if you want to be sure to get the results in a certain order, you have to put an order by at the end of the query. And a very common bug that you see in applications is, like you even saw me do earlier, or even saw me, but I also did
you
that.
You did that?
Right?
I didn't see that.
So often it's important that the order by is unique. Right, so that's why I added this transaction ID in there. So let's go ahead and run this query. And now you can see that the balance is, I called that one final balance. Let's call that one current balance, just to be clear. So now you can see how the current balance is increasing as we go, because it's the sum of the current row and all rows preceding that.
Correct.
And you may argue and say, well, okay, why does it do that? It just said order by. That doesn't really make sense. That is part of the ANSI specification of the language, that if you say order by, it's implicit that you're using a framing clause to say, will only include a certain amount of rows. So what's the syntax for this? Can you show the PowerPoint slide again?
I certainly can. Which one are we looking for?
Oh, no, and now I remember. So
Got it.
rows between current row, rows unbounded preceding and rows, now that we're seeing between unbounded preceding and current row. I think something like that will make sense. We'll see. Yay! Okay.
Nice.
So this is what this actually means implicitly. It's actually values between current row and or unbounded preceding and current row, but you can read up a bit on the differences. But basically now it makes more sense, right? Okay, for each account, sort the result like this, and now for this particular row, include everything from the beginning of the partition or the frame, i.e. for this account, from the beginning of the transactions for the account, up until this row. And you can also say, starting at this row, between this row and unbounded, following, if you want to go forward instead.
Okay.
But this is obviously super, super useful if you want to do calculations like this. And you can imagine just by looking at the result set that this is fairly common, right? The running total.
Yeah.
And this is super, super efficient, the way we've implemented it. The other thing that's very interesting is lag and lead. So I'll show just a quick example of that. So let's just say we have the production product table. And, or let's actually continue with this set since we have the example running. So let's say, okay, this is all nice, but I want to see what is the difference between the current transaction and the previous one. Right?
Okay.
Which is a very common thing that you want to say, well, what's the difference between this and the next row in the set, or the previous row in the set, or the 5 rows back, or whatever. This is very common calculations.
Yeah.
So then what I can just say is, okay, please grab me lag. I want to go backwards in the set, and I want to grab the amount column, and this is an expression, so it could be amount plus something, whatever, amount, and I want, default is to go one step back. So I want to get one back, and then if there is no row preceding, right, what would I like to get? Well, if there is no row preceding, I will get null back, but I can say, well, then please give me 0 instead.
Okay.
So lag, and obviously lag is the same thing. It requires an order. So we say, well, this is over for the account, within this account step back, right, and give me based on the same order by clause, so order by transaction date, transaction ID. So now it knows, okay, go one step back and grab me the previous amount. So we can just see this query. Now we can see, okay, this is the previous amount. We see there is no one before, so that's 0. And you can see how these match up as we go down. And then obviously I can say, well, what is the difference now between amount and the previous amount. Or this amount, is it bigger or smaller than the previous one? And now we can see, well, this is obviously bigger than there weren't any previous one. This one is this much bigger, this much smaller, and so on. And this is just kind of tickling your interest, but you can imagine you can do a lot with these calculations. And it may seem a bit intimidating if you're looking at it for the first time, but this is really a recommendation. If there's anything that's useful, it is this. Lots of calculations can be done there. It's not very hard once you get to know it, which is obviously common. Like English is not hard if you know it. Swedish is also not hard if you know it. But if you're interested in SQL, you should spend some time reading up on window functions and playing around with it.
What's that calculation from Fahrenheit to Celsius? That's difficult. Oh, this is easy compared to that, isn't it?
Yeah. That's why who is it in the world that use Fahrenheit again? Can't remember.
What country? Oh, Canada.
I thought they used Celsius.
I don't know.
And we all know Celsius is a Swedish dude, just to be clear here.
Yeah, you mentioned that earlier. That was good, definitely.
Yes.
All right, let's move into grouping sets. We're going to talk about grouping sets. And in here, we're going to talk about pivoting. So pivoting is kind of unique in the sense that what we do is we take the rows. So we've got this category, quantity, and order year that we have here. And then under category, we got different items, different products, and quantity and order year, excuse me. Now what we do is we can spin those and kind of rotate the columns. So under category, we maintain, in this case here, the beverages. But now we've created a column for each of the years that are available for beverages. So this is called a pivoted table. So we create distinct values from a single column, and we set up the headings for other columns, and these headings can include, or information in these columns can include aggregation. So this is a pivoted table here. So a sample query of this would be select category, and here's our years 2006, 7, and 8. And then we have a from statement, select category, quantity, and order year. From sales category, quantity, year as D. And then we pivot, and we're going to sum the quantity for the order year in 2006, 7, and 8. So the grouping is the category, as you can see here. The aggregation is the sum quantity that we've seen. And the spreading is how do we want to separate this out, 2006, 7, 8, or by year. And then we set it up as, we give it a name as PVT, so that way we can see that. So when we've done that, let me actually go back so you can see what it looks like here. So that's what this brings out for us with that query. It gives us this information that was normally over here with dairy products 2006. And you'll see under 2006 there's a total of 2,086. Well, right here we see 5. Well, it's doing a calculation for us. And it's rotating the content that's in this table into this pivot table and then storing that information in there using this type of command. So the grouping determines the elements that get populated in the result set. The spreading provides the distinct value that we're going to use, and then the aggregated function, in this case here, is the sum that we're going to use. So we get a sum in that instead of individual items that we have set up here. Or am I going the wrong way here? We're going to go back the other way. All right, so here we are. So here's another example of this. Select vendor ID, and we're going to set this up 250 as EMP1, employee 1, 251 is employee 2, all the way through employee 5. And then from this, and then we're going to do a select statement from the purchase order ID with these items of employee ID, vendor ID. And we're going to grab this information from the purchase order header information, which we're going to retitle or as our alias it as P. And then we're going to say we want to pivot, create a pivot. And then we're going to count the purchase order ID for the employee that's in this table, these columns, 251, 250, 51, 56, 57, and 60. And as pivot, and then order by pivot dot or PAVT dot vendor ID. And what we'll do here, because we did the order by, you'll see that these are going to be ordered in 1492, 94, 96. And then for each employee, employee 1, 2, 3, 4, and 5, which are associated with employee numbers 250, 251, 56, 57, 60. This is the vendor ID or the information associated with that.
This all sounds super simple.
Sounds super simple.
This is one of these clauses that always gets me confused myself. But it's actually following the ANSI SQL standard. It's worth noting that pivot and unpivot, or actually pivots especially, is not super heavily used, just because it's very common that you do this type of pivoting in whatever reporting type of application you're using. Either you're using Excel reporting services or you're building your own, rather than doing it directly in the SQL statements. There are definitely reasons to go and use this, but it's worth noting that typically you do this type of pivoting up in the application layer.
So then you mentioned the UNPIVOT. We won't get into this, but here's an example of this, so you'll have it. This is a create a table, and this actually does the opposite. It unpivots, and you insert values here, and then you generate something. And this is down here. I just squeezed in just of what the output would look like. Vendor ID 1, employee EMP1, orders are 4. So we're kind of doing the reverse.
Yeah, and this is actually more interesting in a sense, or more common, I'd say, because it's fairly common that you see just table structures where it's basically not normalized in a reasonable way. So the table actually includes, whatever year, and then employee 1, 2, 3, 4, and you want to write a query on top of that. Then you can use UNPIVOT to actually get it into a more normalized form, and then you can query on top of the output of the UNPIVOT. Because obviously UNPIVOT can be part of a common table expression, derived table, view, etc. So UNPIVOT is actually probably more common that you'd use than pivot in regular queries.
Especially in unnormalized data, it sounds like. If you got unnormalized data, it's a little bit easier to get that content out and slice and dice it the way you want it to, being it wasn't populated correctly in the first place. But writing queries with grouping sets, subclause builds on your T-SQL group by clause, and that allows us to create multiple groupings. An alternative use is the union all, which was demonstrated earlier on. But this is an example. I don't know if I have an example in here. I do. We do a select territory ID and customer ID. We're going to do an aggregate function of sum as total amount due. And then from the sales order table, header table, excuse me, we'll group by. And then we're going to use grouping sets. We're going to have a group set of territory ID and customer ID. And what I did is when I created this, there were several hundreds of rows. And I took this information from towards the bottom because a bunch of territory IDs were blank or null. And so down towards the bottom where we got some valid information, you see the territory IDs are grouped now, and then we'll have the total amount for each of the territories. So this with a grouping set here provides this information per customer ID for each of the customer IDs here.
Yeah, we'll go into a demo in a few slides and look a little bit more into the details of this.
Cubes in ROLLUP, or cube in ROLLUP. Provides shortcut for defining these group sets. It creates a cube, creates all possible combination of grouping sets. In this case here, we're doing a select territory ID and customer ID, again a sum for total due. And we're going to ping the sales order header table. We're going to group by, where you throw in the word cube in there, again territory ID and customer ID, and then we're going to order it by territory ID and customer ID. The ROLLUP is very similar in the sense, but it provides a shortcut for defining the group sets, creates combinations of assuming input columns from a hierarchy. So this is more of a hierarchical approach than the cubing when we use the cube process, I should say. So we've got a couple of these options that are available to us for summarizing our data instead of looking at the details of information, giving a summary of data. So working with pivot, cube, and rollup. Now I said you may not want to work with the pivot so much, but whatever you feel like demoing.
Yeah, I think we'll just basically show just a little bit of what's going on here, and it's actually just simpler than what you would imagine. So let's just say we want to get total sales by customer and territory, right? So we have customer ID, territory ID from sales customer. And then I'll go ahead and just join this with sales order header. And then go and join it with sales order detail. So there we go. We have the kind of the join, and let's just say I want the total sales. So I want the sum of sales order detail. I think it's unit or line total. I think we even have there as total sales. And obviously I now need to go and group by these two columns. okay, so that's great. I get now the total sales for this territory and this customer, and if you scroll down, there are different customers, and scroll down more, we get total sales for customers in different territories. And if it happens to be a customer that are in multiple territories, then which can't happen per the schema, right? But then you would see obviously the reverse. So this is all great, but it's likely that someone is going to ask the question, well, what is the total sales for the customer independent of territory, or for the territory independent of the customer? Mm-hmm. And then without these grouping sets and whatnot, what you would typically do is you would add another query separately and just have the sum there. Let's say we want the total sales, and that would be this. And then you say, well, I want this in one result set, so I'll go and put these both together,
nice.
Right?
Yeah.
And I'll just say order by customer ID in the result set. Now this won't work since I have 3 columns up here and 1 column down here, so I'll just say, well, this returns null for these 2 columns, and now the result sets match and I can put them together. But obviously there is a lot of writing that goes on here in order to get this result set, and as we all know, the more code you write, the more bugs you'll put in there, right? Yeah. So less code equals less bugs, which
that's true.
So
definitely true.
If I instead do this, I'll just say, well, I want to group by, and I want to create grouping sets. So now I can say, not just this is the final and only, I can say, well, I want one set is please group by customer and territory ID as a combination. This is exactly, just running this is exactly the same as the first query, right? Mm-hmm. And let's add the order by as well. But now I can add other sets that interest me. So if I want this total that I just shown, I can just add an empty set here, which means that's the total across all customers and all territories. Now I have the same as the previous query, but clearly less writing.
A little less code, definitely,
yes.
Yeah.
And now I can go and say, well, I'm interested also in actually the total for the territories independent of customer as well. So now I'm getting, first, this is the total sales all up, and then per territory, what's the sale? And then I get per customer. So I can go with, with grouping sets and basically add the groupings that I'm interested in using. Another thing that's interesting to note here is how do you know if the null value returned is actually because there is a null value that you're grouping together, or it's a null value generated by these grouping sets? See the difference? Like here, I just happen to know that there is no customer with customer ID null and no territory ID null, so I know this is the aggregate. But it could also be the sum of all sales for customer ID null, territory ID null. Right. So there is a function called grouping that you can use to find out with a case expression. If grouping for a column returns 1, that means it was a generated null because of the grouping. Oh. And if it returns 0, it means it's an actual real null value, if it happens to be null. So that's interesting. You can then differentiate between null values that you're actually grouping over versus null values being generated.
Very nice. And I like the fact there's less code, less chance of an undocumented feature. I prefer to use that versus a bug. Undocumented feature, that we don't introduce that instead. So that's good to have that. Okay, so what we looked at here is working with sets and the interaction between sets of data results that can be combined, compared, or operated against. The order by is not allowed in the input queries. Set operators include the union, the intersection, or the intersect, and the except and the apply. We also had examples of the union, all, the intersect, and except, and they're using the AdventureWorks database, so these will work within the AdventureWorks database. I know a couple people chatted in and asked, hey, where do I get that? So a couple people asked, well, first off, where do I get a free version of SQL Server? So there's a SQL Server Express version that you can download and install, and then you can install the AdventureWorks. So everything that you're seeing here that you want to dabble with, you've got the ability to dabble with this without writing a big check. Get the SQL Server Express version. There are some limitations, so you couldn't probably bring it out in a real-world production in a big environment. But and then you can use some of these queries that you're seeing, and then you can set up the AdventureWorks database, so that way you can execute these queries against that database. We also introduced some Windows function, the rank, the dense rank, the row number, the entile. We also set a cool demo on the lag. And we have some other offset functions like the first value and the last value that we looked at. Pivoting, probably not something you want to spend a lot of time or lose any sleep over, but the non-pivoting for an unnormalized data would be beneficial for you. Grouping set, as you saw, was really helpful. And then we had the cube and the rollup that are available for us for grouping sets of content. So that's going to wrap up this section here. So what we'll do at this point is we're going to take a 10-minute break. We're going to get prepared for our next section, and Module 6 is coming up. So we're going to ask you to step back, take a breather, take a 10-minute break, and we'll be back with you shortly.